everybody? So, actually we say New Year has come, new month has come. That means we are losing our life day by day, right? Aren't you getting older? Don't think that, sir, we are not older. You are also getting older. You became one day older than yesterday, right? And some juniors are there having long junior. And buddhiless. What to do? There is there no. He thinks life is full of PUBG only. PUBG life. No, if you want to play PUBG, no problem. Which mobile is much more better? I found one mobile is much better. Honor Magic 6 Pro. You might not have heard its name. Best game. But I am not doing advertisement. Otherwise, you say, sir, you might have got some money. You are doing advertisement. No. So some gas is already completed, and we are discussing about metals and Ritika. She presented. So this is a class 9. Class 9 slide observation and talking about class. There are different steps in metallurgy. First of all, crushing and grinding, changing big particles into smaller one. Then concentration of ore, removal of impurities. Different methods are there. What is the first one? Hand picking. Removing big particles with the help of hand picking. Gradual separation. Heavy particles are removed by using water. Third one is magnetic separation. What is third?
Magnetic separation.
Magnetic separation is here. Magnetic and non-magnetic substances, they are removed. So, and those non-magnetic materials present in the ore, they are called gangue. Not dengue. Sometimes we may hear like that, right? It was said that advertisement, mango fruity, fresh and juicy. But while hearing, they are different things. Sometimes it happens. That's why it is gangue, not dengue. Gangue, non-magnetic material. Froth flotation. If the useful thing is in the form of ladder, that is froth flotation. Chemical process reaction with sodium hydroxide. Roasting, heating at high temperature in sufficient amount of oxygen. So it is suitable for sulfide ore. Which ore? Sulfide ore. Look at the chemical reaction here. Zinc sulfide reacts with oxygen in presence of high temperature and forms zinc oxide and sulfur dioxide. Our main intention is to obtain oxide ore from that ore or change that into oxide ore. Lead sulfide changes into lead oxide. Copper sulfide changes into copper oxide, right? And again, copper sulfide reacts with copper oxide, forms copper and sulfur dioxide. In this case, we have got pure copper. In calcination, the ore is heated at low temperature. So carbonate ore is heated, zinc carbonate is heated, calcium oxide, zinc oxide, copper oxide, they are formed, and those impurities react with sulfur and forms sulfur dioxide or phosphorus pentoxide. Pentoxide. Now I think there is next presentation. The presenter is going to explain about differences between the roasting and calcination, Because what happens to that ore, it was said from here. Reduction of metal oxide to free metal, smelting, calcination, roasting, smelting, we have to remember. And reduction by carbon. Next one is reduction by aluminium, electrolysis reduction, refining, electrolytic refining, distillation, liquefaction, oxidation, refining, and finally, she may tell about gold. Yeah? So today's presentator is none other than Luniva Manandhar.
Roasting is the heating of metal ore in the presence of excess of oxygen. Calcination is the heating of the metal ore in the absence or presence of limited oxygen. Roasting is done for sulfide ore. Calcination is done for carbon ore. Reduction of metallic oxides to free metal smelting. The process is carried out after the calcination or roasting of ores. It is used for the converting metallic oxide into metals, generally reducing agents like coal, charcoal, carbon monoxide, zinc.
Nani, you underline that what you are reading and writing.
The reduction of metallic oxide to metal is done by following process. Reduction by carbon smelting. Smelting is a process that uses heat and reducing agents like coke to convert oxide ore into the molten metal by removing oxygen. Refractory impurities which do not melt at high temperature remain after roasting and calcination. Smelting is a form of extractive metallurgy. Reduction of aluminum. Some metallic oxide like chromium oxide and manganese oxide cannot be reduced by carbon. This is because oxygen has a higher affinity with the metal than with carbon. In this case, aluminum is used as a reducing agent for the reduction of metallic oxide to metal. Electrolytic reduction. In this method, the ore is melted for electrolysis. Reactive metal like potassium, sodium, calcium, and aluminum cannot be obtained by heating with carbon. They are too reactive and have more affinity for oxygen than carbon. So we use electrolytic reduction or electrolysis to obtain them. Refining. Metals extracted except through electrolysis often contain impurities such as other metals, reduced metal oxide, and non-metals like silicon, carbon, sulfur, or slag. Various techniques are used to obtain high impurity from metal from crude ones, depending on the difference in the properties and impurities. Some of them are listed below. Electrolytic refining. It is the process of refining a metal by the process of electrolysis. In other words, it is the process of refining metal in which the impure metal is made strip of pure metal is made. Distillation. This is useful for low boiling method or volatile metals like zinc, mercury. An impure metal is evaporated to obtain a metal.
That's the thing. Then what is being discussed?
In this method, the low maintenance metals like tin and lead can be made to flow sloping surface. In this way, it is separated from higher melting impurities. Oxidation refining. In the oxidation refining, metals like iron with impurities such as sulfur, phosphorus, and carbon are purified. Air is passed through the molten impurities metal, and the impurities react with oxygen from the air, turning into gases. These gases escape, leaving pure metals behind.
Okay, let's do that much only. The remaining you will present on next day. Okay? Thank you very much. They need to do some work as well, right? So, presentation is very important. So you are making slides, and some of you are doing animation also. I think there was animation in Ritika's slide, right? To make animation, it will be more interesting also, and it is more convincing as well. Okay, so she has just said about calcination and roasting. Both calcination and roasting are the methods in which ore is heated. But in roasting, it is heated at high temperature. There is more oxygen. In calcination, it is heated. There may be limited oxygen or no oxygen. Matter is like that. Okay? So, in roasting, heated in presence of excess oxygen. Absence or limited. And for sulfide ore, for carbonate ore. Would you remember the 4 types of ores? Sulfide ore, carbonate ore, oxide ore,
and
sulfur. The sulfide is here. Sulfate, sulfide, carbonate, oxide. These are the 4 different types of roasting we have to remember. And reduction of metallic oxide. Okay, by the help of roasting and calcination, we will get oxide ores like Na2O, for example. Na2O, oxide ore. Al2O3, what is this? Oxide ore. MgO, what is this? Oxide ore. These are all oxide ores. These oxide ores must be reduced to metal. That means this is extra, oxygen extra. Oxygen is extra, oxygen is extra. Oxygen is removed, then pure metal is obtained. Oxidation and reduction, you have to keep in mind. If oxygen combines with the metal, that process is called oxidation. If oxygen is removed from metallic oxide, that is called reduction. Means, if I write here Mg plus O2, so MgO, see, oxygen is added to this metal or not? This is called oxidation. What do you call it? Oxidation. But PbO arrow Pb plus O2. See, here was lead oxide. Now lead oxide is heated and lead and oxygen are. Then this is reduction. Removal of oxygen is reduction. Addition of oxygen is oxidation. So mainly here we have to find out reduction method, yes or no. So metallic oxides are converted to metal, and to convert metallic oxides to metal, we use reducing agent. Reducing agent means these agents helps to remove oxygen from metal oxide. Like one Maharaj coke, carbon or charcoal, coke, same thing. Carbon monoxide, zinc, etc. Some terms we have to keep in mind. It is said calcination, heating ore at low temperature, especially which ore? Carbonate ore, to get metal oxide. Roasting, heating sulfide ore at high temperature to get metal oxide. In that way, you have to keep the terms in your mind. Now, again, here in one term, smelting, not smelling, smelting means what is here? The process in which oxide ore is heated with carbon and pure metal is obtained. Oxide ore means like MgO, magnesium oxide, is heated with which one? Carbon. If you say coal, diamond, graphite, these all are carbon. Granite is not carbon. Granite is different. Graphite, the pencil lead is carbon. Diamond is carbon. Coke, COK, coke is carbon. Lamp black is carbon. Girls use gazelle, that is also carbon. From that dew they make, right? Yes or no? Dew. Oil lamp. When the oil lamp is covered a little bit, not completely, something is kept up, then black thing is collected over there. Yes, sir. And later on, but nowadays I haven't seen the girls using such type of things. Earlier, many girls using. Yeah, but these girls are so simple, and we don't allow them also. Right? If we allow, they become more beautiful and handsome and come both combined. So MgO plus C heated with carbon and Mg plus CO2, carbon dioxide, right?
Yes.
That is called smelting. Oxide ore heated with carbon. But this method, smelting, may not work for all. If oxide ore cannot be converted into free metal, then another thing, what to do? Reduction by aluminum. Some oxide metal are heated with aluminum to get free metal, like chromium oxide and manganese oxide. MnO2, manganese dioxide is here, plus heated with which one? Aluminum, not carbon here. Then Al2O3 plus what is from? So different techniques are there. All methods means same method cannot be applied for everything. Some metal oxides are converted to free metal by heating with carbon, heating with aluminum, and if it cannot be done, electrolysis reduction. In electrolysis reduction, what is done? Very simple. They take one container. It is called voltameter. What is it called? Voltameter. And in voltameter, they use some metal plates. How many plates are there? Metal plates. For example, you want to obtain gold from gold oxide. Suppose there is gold oxide, or this is silver oxide. Silver oxide means Ag2O. Silver oxide. And it must be connected with battery or electricity cell, and which is connected to positive terminal. What is it called? Cathode. It is called anode. Which is connected to positive terminal is called anode. Anode. And it is called cathode. Very confusing, eh?
Yes.
Positively charged ions are called cations, Cations go towards negatively charged this plate, that's why it is called cathode. And negatively charged ions are called anions. They go at anode. Okay, opposite charges they are together. And we use here one liquid, one salt of the metal. So this vessel is called voltameter. We are talking about electrolysis. Okay, what are we talking?
Electrolysis.
Voltameter. And this is called electrolyte.
Electrolytes, yes.
Electrolyte means solution of the salt of the metal. Solution. Solution of metal salt. And cathode anode. Suppose this is silver oxide. We want to obtain pure silver means this must be, what is this?
Pure.
Pure. Pure must be kept at negative side and this is impure.
Impure.
Okay. When the switch is made on,
Yes.
then this liquid breaks down into ion. Breaks down into ion. Like suppose this is AgCl. What is this? Silver chloride. So when electricity is passed, then AgCl breaks down into two radicals. What are they?
Ag plus Cl plus minus.
Ag plus and Cl minus. Now this liquid contains which one?
Ag
Ag plus,
Cl minus.
Ag plus, Cl minus. Ag plus, Cl minus. Ag plus, Cl minus. Right? If so, Ag plus, where does it go? In this cathode, and it is collected here. It is collected here, right? Understood or not? Where does Cl minus go?
Cl
Cl minus goes here.
Yes, negative.
And when it goes here, it also becomes,
Ag
it also becomes,
Ag plus.
it doesn't become Ag plus, because it's negative side. It becomes Ag plus. That Ag plus reacts with
Cl minus.
Ag plus
Cl
reacts with
minus.
Cl minus, and what is formed here?
AgCl.
So AgCl liquid is being produced, and some atoms of ions Ag plus reach here, and it becomes thicker, thicker, thicker. It becomes thinner, 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 because it loses. So it loses silver, and see, this is called which method? Electrolysis. Pure metal, cathode, impure metal, anode. Then salt of the metal is used as electrolyte, dissociates into ions, and at the end of electrolysis, nothing will be left in anode. Cathode becomes thicker due to deposition of metal. Three methods are there to obtain pure metal. What are they? Reduction by carbon, smelting. Reduction by aluminium, reacting with aluminium. Next one is electrolysis process. Electrolysis is applied and at the last. And when electrolysis process is applied, we will get pure metal.
Pure.
Understood or not? Pure metal. See, metals are very complicated, isn't it?
Yes.
But we are fond of wasting the metal. But how difficultly they are obtained. Right? So, we have remembered, no? 3R, reduce,
Reduce,
reuse,
and
recycle.
Yes.
Right? These things, they are very important. We have to follow it. This is the one? Where are the other side? The side right here? Okay. Smelting done. For refining, now to get final one, which is the best one?
Electrolysis.
So by electrolysis we can get
Pure.
100% pure metals. So that method I will show you. And not only electrolysis, other methods are also there for refining. Next method is, what is that? Distillation. In distillation, what is done? When there is metal and impurity together, it is heated and the metal changes into vapor, and again they will cool and get liquid form and make solid. We know these things MP and what is here? BP. Melting point and boiling point. Melting point means temperature, it's not point, don't say. Temperature at which solid changes into liquid, that is melting point. We have here water.
Yes.
Keep that down. Down. Down, completely in the ground. Now touch with elbow that shoes. Touch. In distillation, metals whose boiling point is low,
Oh, yes.
they can be extracted, heated,
Yes, heated.
liquefied, and solid.
Solid.
Next one is liquefaction. Some metals they can be separated by liquefaction. One thing remember, in our village, some of the people used to come and they used to make idol from the item which is given by us. Murtis, you know?
Murtis, yes.
Have you noticed?
Yes.
So they say, hey, do you have any bhanda koda?
Yes.
They say, yeah.
Yes.
Hey, they used to heat it,
Yes.
and then that liquid is formed on it.
Then
And that liquid that is kept in
Yes.
one dye here, sensors, and different things.
Yes.
Yeah, means that is liquefaction.
Yes.
Even if it is kept in sand, nothing happens.
Yes.
So it gives like that, right? That is liquefaction. Okay. Next one is oxidation refining. So in oxidation refining, what is done? Metals like iron with impurities sulfur. Iron contains sulfur, phosphorus, and carbon are purified by passing through air. By passing through air. Air means what is the active gas? Oxygen. And they react and free iron is right. So this is the way to learn, remember. Once again, give a glance upon that subject matter portion and write your lovely note yourself. Okay? Come on.